You're watching The Dish TV, the talk show from SRI International that highlights the most important part of our institute, our people. I'm Renita Malhotra Hora, Head of Marketing and Communications, and today I'm joined by Thomas Lowe, Director of SRI Robotics. In part 2 of this interview, we talk about SRI Robotics' unique approach to solving customer needs.
A lot of our commercial customers come to us with very, very broad needs. Perhaps they don't know that they're looking for a humanoid robot to race a motorcycle, but they have a broader objective. And we'll hold a workshop. And in the case of Yamaha, we spent, I think, 2 or 3 days together with them after a long period of remote discussions and presented to them a bunch of technologies, a bunch of capabilities that we had, as well as ideas for how they could take those ideas, some of those ideas forward. Now, in the case of Motobot, it turned out that there were many technologies that SRI had developed that enabled us to build this system where many other companies, most other companies, wouldn't have been able to do so. So as it turned out, not only did we help Yamaha understand what they might do to achieve their objectives, but we were able to actually help them execute that plan.
Now, when you say many other companies would not have been able to help them do so, what is it that is different about our approach to this? What's our secret sauce without giving away the secret?
Unlike a lot of robotics companies today that focus almost exclusively on software, we look at both hardware and software as both being ripe areas for innovation. We create component technologies, sometimes to solve a particular problem, usually for the US government, and those component technologies enable things to be achieved that you can't do by buying parts from a parts catalog like most companies would. So whether it be a new type of motor or a new transmission or a different power supply or electronics that's more efficient, going into Motobot, technologies from our humanoid robot systems, from our exoskeleton robots that we developed for DARPA, all of these things were what made it possible for Motobot to be created. And if we had just bought what we could find online, we wouldn't have achieved nearly the performance.
So we had Alex Kernbaum on this show earlier talking about the Abacus drive.
Yeah.
This particular kind of component, was that used in Motobot?
We had just completed a program in developing a humanoid robot, and Abacus was one of many technologies. Inception Drive being the other, both of which we were deemed a little too risky for the humanoid system. So to create the humanoid in a short period of time, which I think was under a year, we developed a cycloid transmission that was incredibly efficient. And it turns out that that cycloid had exactly the characteristics that Motobot needed to be able to operate safely in the event of some power failure during racing.
And what kind of characteristics are those?
Everyone knows that if you take your hands off the steering wheel on a motorcycle or a bicycle, it will do just fine. If you could just lock your arms and not let them move at all, a bike or motorcycle would fall down within seconds.
Right.
It's the free nature of a human's arms that allow the bike to be stable by itself. And we knew that there would likely be a point in racing the Motobot that we would lose control. And we wanted to be able to just turn the power on the robot off and know that at least the bike would stay upright.
I see.
And it would go straight, and we could put the brakes on, and maybe we could stop it before it left the track. If we had locked the steering wheel or the handlebars in position, the bike would just fall over. And if we were doing 150 miles an hour, it would be really bad.
Obviously, a humanoid is created to mimic a human, if you will. So I understand that. But what was the need to create a humanoid to sit on the bike? Why not just have the bike ride itself?
If we're testing a bike, we want to have a human-like mass and a human-like air resistance on the bike, because without that, the bike doesn't behave the same way it would with a rider. So if we're interested in getting data about how a motorcycle runs with a person on it, we need a person-shaped, person weight, object on the bike with the same center of gravity and the same general characteristics.
Would that go for all vehicles, bikes or not bikes?
Not so much. Really, in an automobile, the size, the weight of the passenger or the rider really has very little impact on the performance.
I see.
A human weighs about, well, a typical motorcycle may weigh 400 or 500 pounds. So the weight of a 190, 200-pound person is a significant portion. A car, 3,000, 4,000 pounds, a person makes almost no difference.
Coming up with the idea for that humanoid, was that requested by Yamaha? Did they want a humanoid, or was that SRI's idea?
It grew out of the brainstorming sessions that we had that first few days. We had been thinking a lot about human-shaped robots for operating equipment up until that point. We had just written a proposal to DARPA, and they had specifically asked for a human-shaped robot that could fly airplanes, heavy transport airplanes, because they felt that there was a real demand for that kind of system. Unfortunately, we didn't get the project with DARPA, but I think that tempered our thinking going into our brainstorm sessions with Yamaha.
There are a lot of humanoids out there which are effectively toys.
Yes, yes.
Which is something we don't do here.
No.
But what is our aim, from the robotics lab?
I think long term, we're going to see humanoids interacting with us because of just the way that we as humans see each other and interact with each other. I think we're going to be able to communicate with things that are of the form that we're comfortable with. But that alone isn't enough justification today to warrant the expense necessary to build such a system. We're waiting to see which technologies actually find good commercial markets. We have our own humanoid systems that are among the most efficient in the world. They can operate for the longest periods of time with very, very small batteries. But we've yet to see a really, really compelling application for the human. So we're waiting a little bit, and we'll see what develops in the marketplace.
Why did DARPA come up with this idea or this, want to commission humanoid robots in the first place? Mm-hmm. Obviously, they thought maybe that there would be some kind of good, useful application.
The tsunami in Japan and the nuclear disaster at Fukushima was one of many motivations. Recognizing that the robots that were deployed there failed miserably, it was recognized that there was tremendous room for innovation in the space. They wanted to find a broadly accepted domestic application that everybody could get behind, and disaster relief, or whether it be an earthquake or a tidal wave, seems like a good motivation.